Hi there, I'm David Wilcock. I'm a member of the board of directors of Stavatti Aerospace, and I also star as a producer and a talent in over 100 episodes of Ancient Aliens on History Channel, which has become a very popular show. They rerun it all the time.
The SM-39 is Stavatti's major next-generation air dominance fighter, and it actually came out of a long-standing need to replace not only the F-22, but the F-15 on a global basis within Allied air forces, and of course the U.S. Air Force and the U.S. Navy. We first started working on this design back in 2010 under what was then a next-generation Air Force fighter program. And we came up with 25 different design configurations, many of them twin-engine designs, some of them single-engine designs.
Could I just stop for a second? So just to slow it down, the next generation air dominance, what is the next generation of what, and what is the use of the plane exactly? Because I'm not sure I quite caught that.
Certainly. The nature of this airplane is it's a successor to the advanced tactical fighter of the late 1980s and 1990s. And that was the F-22. And so this is really intended as an F-22 follow-on. It's considered a sixth generation fighter over a fifth generation fighter such as the F-22 or the F-35.
Okay. So next generation means sixth generation. And now I know that with your impressive background in aerospace, you've really been doing this all your life. There are some very exciting materials science breakthroughs that come out of developing something like this. And I know that part of the issue is this is a very, very fast aircraft. How fast does this plane actually go?
Well, this airplane design is a little bit different than other fighters. We went through a period in aviation where we had large engines, and due to composite construction and other material limitations, they weren't going very fast. This particular design is a next-generation fighter intended to operate at speeds of up to Mach 4 and beyond. So it's a
Mach 4.
It's a Mach 4 air dominance fighter. That's not to say it can't fly slow, because it can. It has an approach speed of about 85 knots on a carrier deck. So it can go very slow. It can also go very fast. So it's extraordinary in that sense.
Is there anything faster than Mach 4? We saw the Top Gun movie. He made it to Mach 10 or something.
Sure. Well, there are real aircraft that do fly faster than Mach 4. Of course, the space shuttle regularly does that, or did that. The X-15 flew at speeds greater than Mach 4.
Like on its approach back to Earth?
Well, yeah, in orbit, it orbits at a very high speed. The X-15 got to higher speeds of Mach 7 and beyond.
But you're doing Mach 4 in the atmosphere, not in space.
We are doing Mach 4 in the atmosphere,
okay.
Yeah.
So that's
at about 40,000 feet and above.
Right.
So it's a very fast airplane, and at sea level it has a cruise speed in excess of Mach 1.5.
So if you want to hold it up for a second, or I will, right? We'll start with that. So when we look at the cockpit here, Chris, it's very small. I mean, this looks like it's a massive aircraft.
Well, it is a very big airplane.
Okay.
It's about 72 feet long.
Whoa.
It's intended to be a large air dominance fighter. It's like the size of an F-14 or an F-15 or an Su-27. So it's really the American equivalent of a Sukhoi Su-27 type airplane.
Well, it also reminds me of the one that we saw in the National Air and Space Museum in Washington, D.C.
It's
the
similar,
SR-71.
The Blackbird. It's similar in many ways to the Blackbird, although it's shorter than the Blackbird. It doesn't quite have that mission. It's more fuel efficient than the Blackbird by a great margin. And it will be powered by two next-generation variable cycle afterburning turbofans. And these engines are variable cycle in the sense that they go from being a turbofan to being a turbojet. And at high speeds, it's a Mach 4 turbojet. It operates nearly like a ramjet. And we have a proprietary design for this engine that will be produced by our engine division known as Neothrust, or we can produce an aircraft that uses engines from either Pratt & Whitney or General Electric.
So let's say as a customer, I want to be a little cynical. I want to rough you up a little bit. I want to say, hey, man, you guys haven't built one of these yet. How are you so confident that you're going to break all these records and do all this stuff?
Well, it gets into the fundamentals of aircraft design. A few years ago, it came out that there are next-generation air dominance fighters that are being digitally designed and tested. Well, that's exactly what we're doing. This is a digitally engineered aircraft. It's something that is based upon firm engineering principles.
So does that mean you fly it in a computer?
We do fly it in a computer, and it has been
How does that work?
Well, you have computer simulation software that's quite accurate. It uses panel methods to characterize aircraft flow, and we use CFD, computational fluid dynamics, combined with finite element modeling for structural analysis. So this is something that a great deal of engineering has already been put into it, and the airplane has already been flown thousands of hours in the design process.
And I know that one of our material science breakthroughs on this is going to be the cockpit, because you're going to melt at Mach 4, right? So we have to have new material.
That's probably one of the most exciting parts of the airplane. And this aircraft, it's like the proverbial NASA spin-off technology center, where many of the innovations and breakthroughs from this airplane will be spun off into the private sector and revolutionize everything from cell phones to fish tank aquariums and things like that. We have a new material.
Because you could have a very hard and clear new material for the glass on your cell phone, right?
That's correct. And so we have a new advanced transparent material that's a high temperature material that sustains impact at very high speeds.
Well, we can say it's a transparent metal, right?
It is a transparent metal, that's correct.
So people don't even realize that exists.
Well, it's something that a lot of laboratories throughout the world have been working on for many years. They were developed in different countries like Ukraine and Russia were working on these technologies for a long time, as were laboratories throughout Japan and Korea and, of course, in the United States. And
if I could just interject, in one of my books, I wrote about transparent aluminum. That was in the Ascension Mysteries. And I talk about the prototypes that have already come out, that we've already tested in labs. They're 500% stronger than bulletproof glass.
Correct.
That's just incredible.
Yeah, it's an amazing material, and it comes out of a need to have a bird strike impact resistant canopy. So this airplane is designed to have a bird, like a goose, hit the canopy at about 500 knots.
You might make a lot of people really sad, though, Chris, because if we start making cell phones out of this, when they want to throw their phone and make it smash, it won't smash, right?
No, it won't really smash. So you have a very neat display technology.
So that the cell phone makers might be like, oh no, how can we sell it if it's never going to break and scratch? Have a problem.
Well,
that's for them to figure out.
That's for them to figure out. And that same kind of flat panel screen technology is the sort of thing that we're doing with the canopy. If you notice with our design, we don't have a traditional heads-up display, nor are we using an expensive helmet-mounted display.
Like the F-35.
Like the F-35. Instead, we're projecting all the sensory information directly onto the canopy. So your heads-up display is totally immersive.
Wow.
And this is another proprietary technology that we'll be featuring on all of our military aircraft and many of our civil aircraft.
It does kind of sadden me, Chris, that when you look at the outside of fighter jets, they look really cool. And then when you look on the inside, it's like Charlie Brown.
Well, it is. A lot of the cockpit technology hasn't really kept up with our level of technology. Same thing with landing gear, in my opinion. But this is truly an innovative canopy and cockpit as well.
That sounds really cool.
So it's a very advanced cockpit system. We're still using a very standard F-16 type flight grip and throttle grip. And the reason we're doing that is because the F-16 really pioneered a lot of amazing features with respect to hands-on throttle and stick. And so there's an easy transition from, say, an F-16 type flight control system to this airplane. And that's fairly standard on all of our designs. So while we have a very advanced cockpit, we're giving people a familiar flight grip that has been proven and familiarized, as well as a fairly proven throttle system.
So their adaptation to this aircraft will be a lot faster.
That's correct. So
you don't need to learn all new skills.
That's right. And the airplane itself will be teaching you how to fly it. So this is an aircraft that benefits quite a bit from our synthetic intelligence, which is our approach to artificial intelligence. And the airplane will be able to fly itself if desired. We will be making unpiloted versions.
Well, I'll just say I've seen some really incredible footage of the F-22 and the acrobatics that it can do. And he kind of goes up like this and he's doing all this amazing stuff. So what kind of maneuverability do you have?
Well, a lot of that gets into thrust vectoring, and we also have the 2D thrust vectoring. This aircraft will be more maneuverable than an F-22 in the sense
more
that
maneuverable.
It has a lower wing loading. It has more optimized flaps. The wing itself is, despite its appearances, the wing itself is configured for super maneuverability. And moreover, if you look at our configuration here, we have these very large vortex strakes. These are large leading edge strakes that do two things. Strakes.
You were calling them bulkheads when we talked before, but I'll go with strakes.
Well, they're strakes.
Okay.
And so what they do is, as you're cruising at high speeds, they push the Mach cone way out so that your wing is always inside the shock wave cone. So while the airplane may be flying at Mach 4...
Wait a minute, hold on. I'm not sure I understand the Mach cone.
Okay, so as you're flying, as you approach the speed of sound, there's the sound barrier, so to speak.
So Mach 4 is like 4 levels higher than the sound barrier?
That's correct.
Okay.
It's 4 times the speed of sound.
Okay.
And so what we're doing is there's a shock wave that forms off of any object as it travels at the speed of sound, and its angle is dependent upon the speed. And this airplane is optimized such that as you fly at high speeds, your wing, the actual wing itself, is behind or within the shock cone.
Right. So the shock starts here, but then it has all this time to accelerate before it actually hits the wing.
It's also here.
So this actually absorbs the shock before that happens.
That's correct. It's like a piercing system or on a boat or something like that. It's like the bow of a boat.
Like a catamaran, right.
Correct.
You see these boats with the 3 hulls.
Mm-hmm. That's right. So it's kind of
like
they're
really fast. That's the whole point.
So you could say this is a really fast flying catamaran.
It's a catamaran.
So in that sense, your wing really is never traveling at those high speeds because it's always embedded within the cone. And so that's the cool feature. Additionally, at slow speeds, it does 2 amazing things. One, you've got an aircraft that has a strong vortex coming off of it, and that vortex re-energizes your wing. So these are like canard foreplanes.
Like if you want to pull behind an 18-wheeler and get the, what do they call, hypermiling?
Sure, something like that.
And the vortex from the back of the suction of the air from the 18-wheeler, if you park your car and you just drive in that spot, supposedly you burn less gas. It seems really dorky, but
well, that's,
some people do
a lot of that.
You have done that?
Sure, yeah, it works for me. But in this airplane, it's like you see on the F-18 or on the MiG-29 or on the F-16 to some degree. You got this vortex generator. Additionally, like the F-16, you have your air intakes underneath your vortex generator. So as you increase in angle of attack, you're not cutting off your airflow to the engine. So that's one huge benefit over the F-22.
Because this surface is catching air even as it goes up.
It's pushing the air as it goes up. So
whereas if you didn't have that there, the air would totally cut off. And then what happens to the aircraft?
Well, you could potentially stall the engine.
Oh my gosh.
So
you get more maneuverability that way.
You get more maneuverability.
Oh, that's cool.
It's very maneuverable. And it's something that you find in an F-16, but you never find that in an F-22. You don't find it in an F-35. You won't even find it in an F-15 or a number of other aircraft. Even the F-23, which never went into production, it has similar characteristics in some respects, but not to the same degree. So
if you want to turn it over so we can see the top in the camera here.
Oh, like this?
Yeah. These are the line of the jet. I mean, they got the intake up here, and there's this huge amount of space before it actually exhausts down here. Does that have something to do with why it's so fast?
Well, it sure does. We have a variable geometry air intake system in the aircraft. So we're
variable geometry air intake.
It's an internal compression system. We have large engines, and we're also doing something special with the exhaust. And we can do something special with the air intake. And by special, I mean we can manipulate the air using both temperature and electromagnetic effects. And so this is a stealth airplane. It's a low observable airplane. But low observability isn't just related to the radar cross-section. It's also related to the sound signature, the aural signature of the airplane, how much noise it makes, and also the infrared signature, which is very important. And sometimes...
Right, I remember you said we can't have like a knob or any point that really pokes out on it because that creates a radar signature.
That's correct. And this airplane benefits, it's a next generation stealth technology that is planform independent. And what I mean by that is many stealth aircraft rely upon something known as planform alignment to make sure that they're stealthy, that they don't reflect radar energy back to the receiver. In our aircraft, we've gone beyond that. The material itself on the airplane is configured to enable, it's a active stealth technology. That's probably the best way I can put it.
Configured.
It's more than just, it's not radar absorbent material. And this is a very important feature on this airplane. Many aircraft that are stealth have radar absorbent materials.
Like the bandpass material?
Well, bandpass material or the
and that would mean, just so people, in case you don't know, that there's a material that you go through at the beginning. And the radar, it's partially permeable to that, right? But then there's another part of the material that changes the radar signature inside.
That's correct.
And that's part of how stealth works.
And so it gets stuck. You trap the radar.
Right.
So that's part of what we're doing.
Okay.
The other thing that we're doing is we have an airframe that is much more maintainable. On the F-35, the F-22, even the B-2, one of the major problems is keeping the skin stealthy. And we don't have that problem because we're not using that type of radar absorbent material at all. This is a rugged radar material. It's actually the airframe structure itself. So you don't have to maintain the structure to maintain a stealth surface. It will always be stealthy. And this is a major breakthrough. It saves literally millions of dollars in maintenance costs. It reduces our maintenance man-hour costs significantly.
Well, you talked about stealth butter or stealth putty, right?
Putty. This airplane, it doesn't have any rivets. It doesn't.
Well, let's
have
explain
any
that for those who don't know.
Sure. Well, if you look at an F-22 or an F-35, there's a lot of external fasteners. And those external fasteners are hidden from radar using a stealth putty or a stealth butter, as we like to call it. And so it's a substance that's like a caulk that you put over these fasteners to make them invisible to radar. Well, we don't have any of that. We don't have any fasteners.
But part of the drawback also, though, is that it always comes off.
It comes off.
So everybody is painting putty on the plane every time it lands.
So it's a high maintenance issue. And so we eliminate that problem. So we have an airplane that, especially for naval use, this is something you can put in a saltwater and a seawater environment on a carrier deck and not have your stealth technology be compromised.
So just a very, very simple question. Is there anything better than this once it's built? Anything that would outperform it?
No,
as far as you know?
No, as far as fighters go, no. I know that we're in competition with both Lockheed and Boeing and to some degree Northrop for next generation air dominance designs. But stated frankly, out of the 25 designs that we submitted to the Air Force, from what I've seen that they're working on, it isn't this advanced. It's more like some of our other earlier designs that did not innovate these core innovations. This airplane, when you show up to a gunfight, you don't want to take second place. And this particular
you don't want the slow gun.
No, you don't. And so the way this airplane will terminate its adversaries is it can be cruising easily at 100,000 feet at Mach 4 and wipe you out before you even notice.
Wow.
And this leads to a whole new family of
So that's why they call
systems.
it dominance, right?
It
dominance.
will dominate the sky.
You'll dominate the air.
And so it's an aircraft that will be fitted with our proprietary gas dynamic laser weapons, directed energy weapons. And this is something to be noticed. We're pioneering gas dynamic lasers. We've been doing this for over 20 years. Gas dynamic lasers are different than solid state lasers. They're different than a lot of the other lasers that other companies have been developing and focused on for a long time. And the advantage is that we're drawing laser power directly off the engine system. And that allows
off the engine
system, yes.
Oh my gosh, so you're powering the weapons with the engine system.
We are, and it's the thermal energy off the engine, not the electrical energy. So we're not.
So when you say gas dynamic, is there a hot gas involved?
There is a hot gas involved. And so we're using the state change of a hot gas that's thermally pumped to generate a megawatt range beam. And so this is a multi-megawatt beam that can go over very large distances. And we're using this for both offensive capability as well as defensive. So if we're intercepted by, if we have a radar, if we have a missile threat, for instance, we can intercept incoming missiles, we can intercept incoming drones.
Well, Chris, it doesn't really sound great because, I mean, you've seen these movies, you fire one off and then you hear this beep, and you got to wait for it to charge. And your enemy knows exactly how long that is, and he's just going to nail you before you can shoot another one. Right?
Well, that's what's really neat about this. It's a continuous thermal charge. It's pretty much continuous. I mean, it recharges very rapidly. You're getting out 100 shots per minute or
oh my gosh.
More. It's very rapid, and it's far more lethal than a 20 millimeter cannon round.
And you've said that, basically speaking, the gas dynamic laser makes a lot of these projectile weapons obsolete.
It can. That's not to say it won't carry missiles. And in this airplane, we have 2 weapons bays. That we can carry a rotary launcher. We can carry up to 8 AIM-120 size missiles. And up to quite a few AIM-9X size missiles as well.
Sounds like a lot.
It's a lot.
It can do a heck of a mission.
It can do a heck of a mission. It carries more internally than an F-22 or even the YF-23 would.
Now, could any plane fly a longer mission, a longer amount of distance than this?
Well, that's part of the neat thing about this aircraft. It carries quite a bit of fuel. in its conventional powered version. Conventional powered, I mean, it would be powered by JP8 or other jet fuels, JP5, what have you. But because it's a variable cycle engine and we're using our metal matrix, high temperature metal matrix materials in that engine, we're operating at a higher temperature. And so this engine is thermodynamically more efficient. So we're actually to a point that the afterburner doesn't make that much difference on a percentage basis for the thrust produced by that engine because we burn so much oxygen and so much fuel in the combustion process that we're getting very efficient. So the engine will have about 40,000 pounds of thrust without afterburner and about 52,000 pounds of thrust with afterburner.
That seems like an incredible amount.
It's an incredible amount of thrust, and we're harnessing that thrust combined with the air intakes and the structure to enable you to cruise at Mach 4.
Wow.
Now, you have to remember that the Blackbird had two 35,000-pound class variable cycle turbo ramjet engines, and it was a Mach 3 plus airplane. It was larger than this airplane. This airplane is smaller than a Blackbird, yet it has more thrust per engine. It has basically 20,000 pounds more thrust per engine. So it better go faster than a Blackbird. Otherwise, you're really not achieving very much.
Are we going to have to build our own unique jet engines?
Yes, it will be. It's something that they're either custom produced by Pratt & Whitney or General Electric, or we'll produce them ourselves. And that again is from our Neo-Thrust division.
Well, if I was the customer, I would say I'm very amazed by now. It's quite an astonishing thing. I mean, this is a huge technological breakthrough. And what are we talking about in terms of cost? I mean, we're not going to get specific, but there's been some recent planes coming out.
There has been.
And they're hundreds of millions of dollars, dude.
Well, that's a big problem with the next generation air dominance fighter. And our design is coming in at the same price as a current F-15EX, which is $85 million. We have
That's a lot less than 300.
It's a lot less than 300. And part of the challenge with the aerospace defense industry right now is they're really not addressing customer needs. If you look at where we're at, back in the 1980s, we had a lot of F-4 Phantoms, we had a lot of F-15s, and the F-22 didn't exist yet. You know, we had a big fighter force. Nowadays, the United States and our allies are facing more threats than we ever did in the 1980s. It's a more dangerous world. Back then, we had the Soviet Union and the Warsaw Pact, which was the primary threat, but their technology wasn't considered that advanced. Now we have not just those countries, those nations.
Hypersonic missiles.
We have, well, most of the Warsaw Pact is now allied to the United States. We have Russia now, but we also have China, we have India, we have a variety of nations, all of which have advanced weapon systems. So the countries that we didn't think had advanced weapons do. Now, some of those, fortunately, we're allied with. Now, the Stavatti mission is to use this airplane as a replacement for F-15s, for the long-retired F-14, for the F-22, for the Su-27, those category airplanes. And so we're looking at the sale of this airplane to close allies. And that can be Saudi Arabia, that can be Japan, that can be South Korea, that can be India, that can be Israel. There's a host of customers for this airplane. We're looking at selling 1,500 of these airplanes worldwide, including sales to the United States. So this is something that we're going to be mass producing this airplane at a rate of 50 to 100 per year continuously for maybe a 20-year period. So we could get up to production rates of 2,000. If necessary, we could surge produce this to the rates of the F-4 Phantom, which would bring us up to 5,000 units. But the core goal is that we're selling it at $85 million. It's not a $300 million plane, so that the Navy could potentially have 700 of these, so that the Air Force could potentially have 900 of these. These are aircraft that replace F-15s and the old F-14 on a one-per-one basis.
Actually, for the same money, but you're getting so much more.
You're getting a lot more. And so it becomes a very important project from the standpoint of if the United States wants to be able to project air power on all of its carrier decks, this is the right solution. Now, I'm not saying it's the only solution. I fully encourage the U.S. Navy, the U.S. Air Force to buy 200 NGADs from Lockheed or 300 NGADs from Boeing. That's perfectly fine. But I'm looking at more of a World War II mentality where we had the P-51, we had the P-47, we had the P-38, we had the Hellcat, we had the Corsair. We produced all of these different fighters, and all the different fighter manufacturers had an airplane in either the Army, Air Force, or the Navy. get rid of this concept of the winner takes all and other companies just fall to the wayside. So it's a new paradigm. It's a new procurement paradigm. And it's something that foreign governments, such as India, can acquire this airplane. And
people might not believe that something that's better could cost the same as an F-15EX. What is your answer to that?
Well, the answer to that is airplanes are sold by the pound like bologna. And the reality is
you get good bologna or bad bologna?
Exactly. And so while it's advanced technology, our job as aerospace industry professionals is to bring you advanced technology at the same cost of last year's advanced technology, kind of like with cell phones and computers. If you notice, you buy the best computer in the world, and it always kind of costs around $2,000. That's
Right.
been the case since I remember.
That's right.
The best cell phone in the world, it's going to cost about $1,000.
My Apple IIc, back when my parents got that for me in 5th grade, I was so excited.
Yep,
$2,000.
$2,000. And when I buy a new computer, you can spend more. But it's just like this, and $85 million, that's the base price. I mean, you can top it out with advanced electronic warfare systems and other features and get it up to $100 million if you like. But the baseline aircraft that we will be exporting to allied nations like Saudi Arabia, Qatar, United Arab Emirates, India, Canada, countries like that, Japan, is about $85 million.
So let's say I'm a defense minister and I'm looking at this product, but I have some concerns, like let's say maybe one of my concerns is this really going to do what you guys say it's going to do? It seems like it's a belief system change. So would you say that you said you flew it in computers, right?
Correct.
So the computer is not fooled.
That's correct. I mean, it's a good simulation of what we're doing, and you really can't trick it because we're using we're calibrating the computer system with other aircraft design that we have known characteristics of. So that's how we pit it against adversaries. We flight model an F-22 and we pit it against an F-22 or an F-16. So we're doing the same analysis. But the next stage in our program is prototyping the aircraft.
Right.
And for that, this is a $300 million prototyping effort.
Okay.
That will get the first prototype out. The total development cost of the program is about $3.3 billion to fully develop, fully flight test.
That seems really low for airplanes.
Well, it is for this type of fighter, but then again, we're using it this is a commercial development program.
I mean, I remember seeing how much they spent on the F-35. Isn't it over $1 trillion or something?
Well, it's a crazy number that they spent on development. They spent about $50 billion on development.
Oh, okay.
And then you have procurement. Well, what we're doing with this airplane, we're Stavatti, we're lower overhead. We're kind of like a proverbial skunk works type organization. We're lean and mean. We also have the design. You're not paying us to come up with a concept. We've done all this work for free, so to speak. It's been an ongoing effort, and part of the engineering, we've shaved a lot of costs. We've been pioneering a lot of the digital technology that has been lauded in other circles recently.
Well, I think it's important, and we talked about this privately, but let's do it now, that other product offerings that are coming out now might really just be a sophisticated idea where they design a shape.
That's true.
But what's the difference between that designed shape, the first stage, and what you got here?
Well, this particular design is our 2014 design. And so we decided rather than showcase our production configuration, we will go with the original design that we presented to the Navy when we first started being part of the NGAD industry effort. And the reason for that is it is, of course, a cool design. It looks good, but there's been advancements and modifications recently over the design evolution. So this isn't your final picture, but it's what we're willing to put on display so that adversary threat nations like China aren't going to pick up on the final configuration. So there is a big aspect of that to it. So we're keeping our design secret, our final design secret, but this is our talking point. This is our icon for our particular NGAD solution, the SM-39.
Let me share another thing. Let's say I'm the defense minister, something else that I'm very concerned about. I'm very concerned about maintenance costs. And are you guys going to have my back, or am I going to buy this and then all of a sudden you guys go out of business and I'm out of luck?
Well, see, that's what's neat about Stavatti. We've been in business for a very long time. And we've been doing things since 1994, a lot of that within the classified era. So we're not going away. We're going to be here for the long term. In addition to that, the airplane is designed for maintainability. As you see, It doesn't have a traditional vertical stabilizer. It has a different approach. It's a very low to the ground airplane in that sense. You can maintain most things at waist level. So you can work on it here and here. And so the line removable units, the avionics, it's very accessible. So you don't need the same ladders. In this case, the airplane has its own built-in access ladder, so a pilot doesn't need an external ladder. You have a very standardized support equipment, and of course, with respect to the materials of the airplane, while they're advanced materials, they don't have the same high maintenance characteristics of our traditional stealth fighters like the F-35 and the F-117 or F-22.
So let's say that now I'm telling you, Chris, I want this today. I want to give you the money and I want it today. Can I get it today?
Well, you can put in an order today and you'll get it in about 4.5 to 5 years. And so
because this is a whole development process.
This is a new development process. But the advantage of that is if you look at our competition, if you order an F-16 today, you probably won't get it for 4 or 5 years due to their backlog.
Wow.
So what's neat about this airplane
is... So why order the old stuff? You get the new stuff.
Exactly. Why order...
Same time, same money, or maybe even less expensive, right?
Yeah, same thing with the F-15, which is even older.
Wow. $85 million for an F-15.
That's correct.
And this is the same price.
It's the same price.
It's just astonishing. But I know that it's because we've kept our operations so low.
Yep. Yeah.
Low overhead.
We're a lean organization, and we're not paying we don't have the pensions. We don't have all this additional overhead that many other aerospace companies do. So for the moment, we can certainly offer lower cost aircraft, hopefully for the next 30 or 40 years.
Well, before we close out this video for potential customers, is there anything else that we didn't cover that you'd like to say to our potential customers about this particular opportunity?
Well, this is the ideal air dominance fighter to replace your F-15s, your F-22s if you happen to operate them, or your F-35s. It's an excellent Sukhoi Su-27 replacement. It will come in single seat, 2-seat tandem, and unpiloted variants. And it's probably the most exciting airplane that anybody could possibly fly.
Wow. Well, thank you, Chris, for telling us about the amazing SM-39 Razor. And thanks for watching.